the basics of Unix scripting and the behavior of some command line tools established, we can now move on into getting data leveraging other Unix tools. There are two questions that we're trying to get into today. The first one is, how can you easily get data, ideally in an automated fashion, and how do computer networks work at a generally fairly high level? The second question is important to understand so that the workings of some of the tools make a little bit more sense. The first one is obviously essential to our work because we do want to automate the task of getting data so that we cut down on the effort in minutes or hours that we have to invest in just retrieving data and formatting it, getting it ready for our analyses. If you search Google Images for internet, this is what comes up, a very pop culture level understanding of this resource that we use by now daily to get our email, get our entertainment, perform our work tasks. But that really doesn't have anything to do with how the internet actually works. If you think about it in just the narrowest sense of having one machine, your laptop that you're working on, and one web server that you're trying to get information from, this is the protocol layer that your request is going through. There's an application layer, which is HTTP, the Hypertext Transfer Protocol. As a transport layer, there's an even more fundamental network layer, and then we're on the data link layer, on which then the data can be transferred and moved back up in this protocol hierarchy up to the application layer, where some code on the web server is dealing with your requests and then sending the information back. This is abstracting tremendously from the bit stream that is going through global fiber optic cables to move the information back and forth between you and some target web server. We don't have to go into the details of all of these protocols. This is not a networking course, but I want you to understand that the connection between your laptop and the target web server is encoded through this stack of protocols. So there are many, many different steps that are necessary for the information to move back and forth. In reality, what the network topology looks like for the internet is that we have some host that may be your laptop or some other machine, could be your phone. And then there is a series of routers that directs the traffic from your phone, your laptop, to Amazon, Google, all of these services, and then the same way back. And again, this is just the connection between two hosts through a series of routers. If we think about it from the data flow perspective, which is slightly expanded from the image on the previous slide, what you think is happening is that your application is directly talking to the application on the website, your Amazon shopping cart or your Google request. In reality, what is happening is, again, we're going down to a transport layer where we establish some host-to-host connection that is routed through the internet with some links going through the local Ethernet. So if you're at the university, right, this would be the university net, going out into the global internet, which could be fiber, satellite connections, and so forth, making it eventually on premises of the compute center of Google or Amazon, and moving up the protocol chain to what is, in the end, the application that takes in your search request and is looking for results on the Google servers to then send back to you through that fairly complex network. So all of this, as it comes up throughout this week's package, should encourage you to look back into this generic data flow diagram that I'm showing here, ensuring that you understand that a lot of complexity is hidden from you and encoded in pieces of the URL that you don't need to understand the internal workings of, but hopefully help you to grasp why we touch on these things here, so you can move data from a remote host to your local machine back and forth.